Medi-Together from Dongha University. I'm Min-Yang Kim.
And I'm Sumin Song.
We present Aquaflex, a hybrid AI screening system for laryngopharyngeal reflex. Imagine a patient suffering from chronic cough and a lump in their throat. Naturally, they visit a local internal medicine clinic or a public health center, not an ENT specialist. Because LPR is caused by stomach acid reaching the throat and voice box, it accounts for 10 to 30% of all ENT clinic cases, yet most of the general public has never heard of it. They don't know their symptoms point to LPR, so they are frequently misdiagnosed with asthma or a simple cold. As a result, the acid continues to silently damage the vocal cords. Over time, this leads to severe complications like vocal cord erosions, polyps, laryngeal cancer. LPR is a preventable disease if caught early, but the lack of awareness causes critical delays. This continuous misdiagnosis also leads to doctor shopping, patients wandering between clinics, wasting time and money. The root causes are primary care doctors lack the tools to differentiate LPR, and RSI survey is too subjective. Therefore, we identified a critical need for an objective screening tool that can be used right at the primary care level to accurately triage these patients and refer them to specialists immediately.
Our solution is Aquaflux designed to bridge this gap. While our demo is interactive prototype, it is designed based on a robust supervised learning architecture. Think of it as a classifier function, y equals mx. Here x represents our multimodal inputs, the patient's subjective RSI score, and objective acoustic biometrics makers like jitter, shimmer, and HNR. Y is the predicted risk classification, high, moderate, or low. To train this model, we utilize the AI Hub's Korean voice pathology datasets. We follow the standard protocol of splitting this data. 80% is used for training to fine-tune the model weights. The remaining 20% is the test set to verify accuracy before deployment. If you're high risk, the system tells you your symptoms and voice analysts suggest possible LPR. Please see an ENT specialist urgently. Then this ensures our tool provides a statistically grounded risk assessment rather than a guess. Now I would like to introduce the actual workflow of Aquaflux. When the program is launched, users can select whether they are pigeons or patients. First, I will demonstrate the process from the patient's perspective. To begin the examination, the patients enter their name and date of the birth for identifications. Once verified, the patient's process to the examination guide screen, the patient's response to each RSI items by one, like this. After completing the questionnaire, the system automatically moves to the voice recording stage. During this stage, the patient is instructed to remain relaxed and using their natural speaking voice, sustain the vowel "ah" for 3 seconds. After the recording is completed, the patient is directed to their result page, where they can review their participation status and check their individual examinations outcomes. At this point, the patient's role in the process is complete, and they wait for their consultation with the patients. Next, let's move on to the physician's view. When the physician logs into their page, they gain access to a list of patients who have undergone testing through Aquaflux. The physician selects the patients whose result they need to review. Let us take a look at the result for John, who was tested earlier. Here are John's overall findings. Unfortunately, both his RSI results and his voice recording analysis suggest a strong indication for LPR. Let's examine this more closely. Through the RSI list, we can see the specific items John selected. His voice's recording as compared against the acoustic patterns of LPR patients stored in Aquaflux. In John's cases, the similarity score is approximately 80%, which further supports the likelihood of LPR. Finally, on the final result page, a message is displayed identificating that John is highly likely to have LPR and should visit an ENT for further evaluations.
For real-world implementation, AquaFlux is designed as a web-based tool requiring no app installation, which is vital for high accessibility in busy clinics. Our deployment strategy targets public health centers and internal medicine clinics as the primary entry point. By filtering patients here, we generate significant economic value. For patients, it stops the cycle of doctor shopping, saving medical costs and time. For doctors, non-ENT doctors can refer patients with confidence, and specialists get pre-screened data-rich cases. Regarding safety, we adopt a privacy-by-design approach. Voice data is processed in real-time memory for feature extraction and is never stored permanently on the server. Our team has a concrete roadmap to bring AquaFlux to life. First, we plan to validate our model by collaborating with a local ENT clinic. We will compare AquaFlux's risk scores against actual laryngoscopy results to measure sensitivity and specificity. Technically, while we currently use acoustic features, our next step is to implement deep learning models like CNNs using spectrogram images for higher accuracy. We also aim to expand our training data beyond the Korean AI Hub dataset to include global voice databases, making AquaFlux a universally applicable screening tool. AquaFlux is not just an app. It is a gateway to better throat health, ensuring every patient gets to the right doctor at the right time.